This topic is called area as probability. You might also see it called geometric probability. Basically what it uses is the formulas for area of different polygons and figures, and we need to use that and integrate it into probability. Just as a review for probability, the way that you calculate it for something, and again you want to put this in your notes, the probability of something is the success, the ways that you can get success over total number of possibilities. And you might have done that in like an algebra course where, so like you're tossing a coin, how many ways can you get heads out of the whole thing? What we're going to do is we're going to look at this more in a geometric version, and we're going to just come back to this. So make sure you have that written down, and let's just jump right in. So here's our first thing. We're going to have a circle here, and inside it we're going to have another circle. They share the same center, and I'm going to tell you what some of these, the radius is. For the smaller circle, the radius is going to be 6, and for the larger circle, the radius is going to be 20. We'll say inches here. So we could look at this as a dartboard. You have a game, you're going to shoot a dart. We're going to say that no matter how you shoot this dart, it's going to land at least in the bigger circle. Somewhere in the bigger circle it has to hit. What we want to know is what is the probability that it will land. What is the probability that it will land in the smaller circle? So copy this into your notes. What is the probability that the dart will land in the smaller circle? I could put dots in it and call it the shaded region, but I just don't feel like it. Alright, so if we analyze what we have above for probability, the success we're talking in here, in this problem, the success will be, so let me just put probability of smaller circle equals the area of the smaller circle, because that represents success, over what is the total number of probabilities. We were told that the dartboard has to hit within the big circle. So that means that our total number of possibilities would be the area of the large circle. And that's what we want to apply now. So we're kind of chunking this out. We now need to find the area of the smaller circle, we need to find the area of the larger circle, and we need to reduce it or divide it out depending on how they ask for our answer. So I'm going to just continue the fraction as we go along. Area of the smaller circle, well, we know for circles it's going to be pi r squared. So our smaller circle has a radius of 6. When we square 6, 6 times 6 is 36. So that's the area of our small circle. The larger circle, we have a radius of 20. Again, 20 squared, we need to square that out. 20 times 20 is going to be 400 times pi. So if you can remember how to reduce some things, we have pi over pi. They cancel each other out. There's no more pi involved at all. It's kind of sad if you like pi. We have 36 over 400. Let's reduce it a little bit and see how far, if we can get this down to maybe a fraction that we recognize. I know that 4 goes into both of those. So 4 goes into 36 9 times. 4 goes into 400 100 times. It's not the best fraction. It's hard for me to picture what that means in my head. But it's basically telling me that if I divide this out, or if I can think of what 9 100ths is, the probability that I'm going to hit that smaller circle is 0.09. It's not the biggest percentage. It's not the biggest, considering that if we got 1, it would be certain. 0.09 is not very likely to happen. So I guess you'd have to be pretty skilled to hit that smaller circle. And again, I'm going to add to that my picture is probably not drawn to scale. Now I know it's not drawn to scale, so it could be deceiving. Bottom line, probability that a dart will hit that smaller circle is 0.09. There you go. Let's try another one. Clear some space here. This next problem has a square on the outside, so maybe this dartboard is square. And the biggest point value perhaps is this circle here in the middle. And what they tell us is one of these sides is 9 inches. And I said it was a square, so we'll mark that up. And inside that little tiny circle there, I'm going to tell you that the radius for that is 3 inches. All right, and we want to know what is the probability. I'm going to abbreviate probability that a dart will hit the small circle. Again, I'm assuming that any dart that gets thrown at it will go somewhere inside that square. So we're not talking about any wild darts or anything. So in other words, I'm not playing this game because I'm not a very good dart thrower. Okay. Probability that it will go into the small circle will be success, which represents the small circle. So we need to find the area of the circle, over, since I said it has to fall in the square, the area of the square. So let's just figure that out. For the area of the circle, we're talking pi r squared. They told us that, well, I'll just write it out as an intermediate step. The area of a square is s squared. So now let's put some numbers in here. Pi r squared, they told us the radius is 3. 3 squared is 9. For the square on the bottom, we need to multiply 9 by itself, so that gives us 81. If I think about reducing, I have 9 pi over 81. The 9 can reduce with itself, and it can reduce with the 81. It goes into itself once, goes into 81 9 times. So now we have pi over 9. Again, that doesn't mean anything to me, my brain per se, but if I had to make an estimate, I know pi is around 3.14, so it probably reduces around to 1/3 or 0.33%. But I'm going to use my calculator. This would be my exact probability if I left it like that, but instead I'm going to take my calculator and do pi divided by 9, and I get 0.35 roughly. So there's a 35% chance that I can hit that small circle. That's a heck of a lot better than our last game that we did. That was 0.09, which is 9%, not too good. So that's how you do that probability. Let's try another one. Alright, what I want you to do on this problem is copy it down, hit the pause button, work it out in your notes, then come back and hit play and see if we have the same exact problem, or sorry, the same exact answer. Okay, so we're going to start off with a circle. The circle is sitting inside of a square. The circle is just stretching out to touch the sides. We know that this side is 4 centimeters, which means all the sides of the square will be 4 centimeters. And they're going to draw in a radius for us and tell us that that is 2 centimeters. Okay, and what they want to know is what is the probability that a dart will hit the circle. I'm thinking it's going to be fairly high. That's what I'm guessing. Just because there's only tiny little corners that the circle doesn't cover. So what we want to do is the probability that it will hit the circle means that for success to happen, it will be the area of the circle. Dart has to hit somewhere in that area, divided by the area of the square, which the dart will have to hit somewhere in that square. Okay, area of the circle, it's going to be pi r squared. Area of the square will be side square. Let's put in some numbers. The radius of the circle is 2. When we square it, we get 4. For the bottom of our fraction, we need to square the side measure. The side measure is 4, and 4 times 4 is 16. So now we can reduce the 4 and the 16. 4 goes into itself once. 4 goes into 16 4 times. Write it over to make it look good. Yeah, in my head, I'm already thinking pi's around 3. The bottom number is 4, so we're going to be around 75%, which is a pretty good number. So let's see what we get. We get 3.14 divided by 4. Yeah, 79%, or 0.79. That's pretty darn good. I might be able to win that dart game, or at least look like I know what I'm doing if I play that, and if all I had to do was get it in the circle. Alright, I hope that helped. If you have any questions, come find me and I'll clarify.